This is the key to topic 31, worksheet 4. And in number 1, it asks you to use properties of logarithms to condense the logarithmic expression. So basically, remember that when you're asked to condense a log expression, so to condense a logarithmic expression, rewrite the sum or difference of two more logarithms as a single logarithm. So if you look at number 1, you have two log expressions. And so basically, you want to write it as one single logarithm. The other thing you got to remember, though, is that when you write as one single logarithm, you want that coefficient in front of the log to be a 1. So obviously, this one would not be your choice because that's a 2. Okay, so keep that in mind. So you need that coefficient in front of the logarithm to be a 1 when you condense. So remember though, you need to remember your properties. So let's kind of real quick talk about what properties you're going to be using with this worksheet. So one of the properties you learned was a product rule. So when you take the log of a product with some base b, then you can write the product as a sum of two logarithms. So you have the log of m plus the log of n base b. Quotient rule is division. So when you have the log of a quotient, then that becomes a subtraction, a difference. So that's the difference of two logarithms. So product is sum, quotient is difference. Okay? And then the power rule basically says that if you have the log of some base raised to a power, some expression raised to a power, then you can always take that exponent, see that exponent, and put it out in front. So it'll be p times the log of m base b. And when you condense, when we talk about condensings, we're basically going the other way. So you can reverse those properties. So you see that property number 1, where it had the sum of two logarithms, then you can write it as one as a single logarithm, but you would say the log of a product because that's a sum. Secondly, the difference of two logarithms. Now remember though, they have to have the same base, so keep that in mind. You have to have the same base for these properties to apply. So for difference, you can write as a quotient, so the log of a quotient, m divided by n. With quotient, you got to be careful that first argument. We're going to call this the argument. That first argument goes first in the numerator, and whatever you're subtracting, that argument here will be the denominator. And then when you have some number multiplied by a log expression, you can write that coefficient as an exponent, just like you see here. Okay? All right, so let's look at number 1. So let me go ahead and rewrite number 1, and let's talk about that. So here's number 1. So number 1, we have 2 times the log base x of 4 plus log of 3 base x. So remember, I stated it different ways. So the log 2 times the log base x of 4, or you could say the log of 4 base x plus the log of 3 base x. Notice the bases are the same. So since those bases are the same, I can use these properties. Okay? So I have what I want to do to condense is to write this as a single logarithm. So first of all, keep in mind, see I have that coefficient right here, right? So if you're going to write as a single logarithm, those coefficients here have to be 1s. That's a 1 already. That is not. So when we look at this one here, you're going to use the power rule. So we're going to go this way. So you're going to rewrite this as the log of some argument raised to a power. All right, so basically what that means is that you're going to take this 2 and you're going to write it as an exponent. So this becomes log base x of 4 squared plus log base x of 3. Okay, so once you get this to be coefficients of 1s right here, then we can continue on with our properties. So here I am going to use the product rule here because I'm taking the sum of two logarithms. Before I do that, let's go ahead and rewrite 4 squared as 16. So that becomes the log base x of 16 plus the log base x of 3. All right, and so now I can use the product rule So when I have the sum of two logarithms, notice the coefficients are ones, then I can write as a product. So I just say m times n. So this becomes the log base x of 16 times 3, and then 16 times 3 is 48. All right, and oops, I didn't mean base 3, I mean base x, so that's x right here, x. And so therefore the answer to number 1 then will be letter D. All right, so I'm going to put C work. All right, so letter D. All right, now number 2. So in 2a, we have this. We have the log of 50 plus the log of 20. Notice there's no base listed. You see that? There's no base listed. So remember, there's no base listed. It's understood to be base 10. Okay, base 10. So your common logarithm. So here we're dealing with a common logarithm, base 10. So there's no base. It's understood to be 10. Not 1, because the base can never be 1. It makes no sense. It's not defined for base 1. All right, so that's base 10. Okay, so right away I can use the product rule. I can use the product rule. So when you have the sum of two logarithms, you can write as a product, the log of a product. So this is going to become the log of 50 times 20. First thing I would write. And then now this becomes the log of, and then 50 times 20 will give you 1,000. All right, now remember though, the direction says this: if possible, evaluate log expressions without using a calculator. And notice that right here, see, that's base 10, right? So, and notice that 1,000 I can write as the log of 10 to the third power, couldn't I? Okay, because 10 to the third is 1,000. Then what I'm going to do now is I'm going to use a power rule, and I'm going to move this power, this exponent, out in front. And there's a reason I'm doing that, because remember, it does say, if possible, evaluate log expression without using a calculator. So this becomes 3 times the log of 10. And I want you to notice this. See that log of 10? I can simplify that, because watch. The log of 10 means this. 10, remember the base is 10. 10 to what power is the argument 10? So 10 to the first is 10, right? So that's 1 right here. So this becomes 1. So that's 3 times 1, which is 3. So the answer is 3. Now let's go back here. So I can kind of do the same idea here. So I can say, all right, I have the log of 1,000, right? And I know I can simplify this. I know that that's going to equal some nice number here, because the base is 10 right here. The base is understood to be 10. So 10 to what power is 1,000? Well, 10 to what power is 1,000? Well, we talked about that. That's 10 to the third, right? So the answer is 3. So this right here goes here. So the log of 1,000 is 3. So there are a couple of different ways you could have gotten the answer. So for number 2a, the answer that needs to put here is 3. All right. Okay, now let's look at B. So in B, we have this. So this is 2b. So in 2b, we have the natural log of y plus the natural log of 8. So ln, remember this is ln, so natural logarithm. So remember, the natural logarithm has base e. Base e. So remember that. Natural logarithm has base e. Okay, so notice that the coefficients are 1s, right? The bases are the same. They're both base e, but it's a sum. So I'm taking the sum of two logarithms. So now I can write this as a product. So when I write this as a product, this has become the natural log of 8 times y, like that, or you can write it as natural log of 8y. But since I'm dealing with with two factors, I'm going to leave it as a natural log of 8y, and that's all you can do. You cannot simplify that. So this will be the natural log of 8y. Okay. Letter C. So in 2c, we have this. In 2c, we have the log base 4 of 320 minus the log base 4 of 5. Now this time I'm looking at the difference of two logarithms. Notice that coefficient is 1, that coefficient is 1. So right away I can use that quotient rule. The difference of two logarithms. I can use a quotient rule. So you just write it as a quotient. The m divided by n. The order matters, so this must be put in the numerator, this must be in the denominator. So now what I'm going to have is this. So then this becomes log base 4 of 320 divided by 5. So that's what that is. Okay, now using a calculator, 320 divided by 5 is 64. So this becomes the log base 4 of 64. Okay, now I want you to think about this. So I can simplify this. You know you can simplify this. Think about this. So let's go off to the side and talk about that. So we have the log of 64 base 4, right? So the question is, let's change this to an exponential. So I get 4 to this power. So 4 to this power equals 64. So 4 to what number is 64? All right, what do you think? 3, right? 4 times 4 times 4 is 64. So that answer is 3. All right, so that's the answer to 2C. So 2C, the answer is 3. Okay, letter D. All right, in D, we have this for D. So 2D, we have 5 times the log of x plus 2 times the log of y. All right, now notice I cannot use, see that's a sum here, right? But I cannot use the product rule until those coefficients here are 1. So that's a 5 and that's a 2. So I'm multiplying this log by 5 and multiplying this log by 2. So I must use the power rule to get that coefficient of 1. So I'm going to rewrite this coefficient as an exponent. So I'm going to take this 5, I'm going to write as an exponent. I'm going to take this 2, I'm going to write as an exponent. So this becomes the log of x to the 5th power plus the log of y to the 2nd power. And now I can use the product rule. So then I get the log of x to the 5th, y to the 2nd. And that's your answer. So you have that coefficient being 1, you wrote one logarithm. So I wrote the sum of two logarithms as a single logarithm. And you need that coefficient right here to be a 1. Okay? So that's the answer to D. So in D, you have the log of x to the 5th, y squared. Okay, E. So in E, we have this for E. We have the natural log of x minus 4 minus the natural log of 4. So this time I'm dealing with the difference. So I'm using the quotient rule. Already know though, you see this coefficient here is 1. This is a 1 right there. Although technically you can think of this as a negative 1 because you're adding a negative 1 here. But just think of this as 1, this is 1. So now since those coefficients are 1s right here, I can use a quotient rule. So this becomes a natural log of x minus 4 divided by 4. And that's all you can do. You cannot do anything else to this. Now usually we'll write it like this, x minus 4 divided by 4 in parentheses. So we'll put this argument in parentheses. Okay, so just like it did these right here. All right, so that will be the natural log of x minus 4 divided by 4. Letter F. So let's talk about F. So in F, so 2F, we have this for 2F. All right, we have 8 times the natural log of x minus 6 times the natural log of y. So again, just like before, I got to have this to be a 1 and this to be a 1 before I can use the quotient rule because that's a subtraction. So I'm going to use the power rule first. So use the power rule. So I'm going to rewrite this coefficient as an exponent. I'm going to rewrite this coefficient as an exponent. So remember, you need a condense. So you're trying to take the difference of these two terms and you want to write it as one term, just like you did these right here. So you're trying to write as one logarithm. So you want to write this as one logarithm. Okay, so first of all, we're gonna write this as the natural log of x to the eighth minus the natural log of y to the sixth. And now, since these coefficients are ones, I can write this as a single logarithm. So it'll be the natural log of x to the eighth. This goes first in the numerator, and then, because the order matters when you're subtracting, and this will be in your denominator, divided by y to the sixth. And that's it. So that's 2f. So in 2f, you have the natural log of x to the eighth divided by y to the sixth. All right, now in number 3, they want you to use the base change formula to evaluate the following using your calculator, and it does say round to 4 decimal places. So remember, when using a calculator, your calculator only uses base e. See right here, natural log is base e, and log base 10. Doesn't use any other base. So see, that's base 3, that's base 2.73, and that's base 0.75. So you cannot right away, these are not easily determined without a calculator. All right, so let's talk about what the base change formula says. So since my calculator, I can only use base e, natural log, or base 10, logarithm, then the base change formula says this. If I have the log of m base b, I can change this base to any other base I want to. So this can be changed to an infinite number of bases. So whatever I want to change the base to, though, here's how you write the expression. So the argument will be in the numerator, and the base will be in the denominator. So if you want to change that to base a, you'll say the log of m base a divided by the log of b base a. All right, so how does that help us with 3a? Well, let's look at 3a. Well, in 3a, we have the log of 7 base 3. So remember, I want to use a calculator. So I know that according to the base change formula, I can, if I want to, I can use base e or base 10, right? So if I use base e, remember that's natural log. So I can write this as the natural log of 7 divided by the natural log of 3. Or I can write this, if I use base 10, I can say the log of 7 divided by the log of 3. Okay, so since I'm using a calculator, I want to use base e, the natural log, or base 10. So remember, log of 7 base e, log base e means natural log. Okay, so remember that. Okay, so now you just use calculator. And notice no matter which one you use, you'll get the same answer. But now they did say, though, round to 4 decimal places. So here's what you do. Let's do the first one. The natural log. So you press natural log right here. So you say the natural log of 7. Okay. Close the parentheses. Divided by the natural log of 3. Close parentheses. And then press equal. So that's about 4 decimal places. So 1.7712. So since this is less than 5, this 2 stays 2. So the answer is going to be 1.7712. If you had done this one, you will get the same thing. So the log, see this, I'm press log, so that's base 10 right there. Log of 7, close the parentheses, divided by the log of, log of 3, close the parentheses, and you get the same thing. Okay? All right, B. So these are easy. So in B, you have the log of 6.8 divided by, with base 2.73. Make sure the base looks like a base, and always remember when you deal with this, the argument has to be level as the letters log. Okay, so the log base b. So make sure you know how to write these. Log of 7. See how it's, if this was a lined paper, see how this is horizontal right here, and the base is 3. Okay, make sure you write this correctly. All right, now looking at this, you can't determine this without using a calculator. So see, it's not as easy as this one. So for example, if I had the log of 8 base 2, okay? You see, you don't need your calculator for that because you can determine that easily. Because watch, 2 to what power is 8? Well, 2 to the third, right? So the answer there is 3, 2 to the third. So if you use your calculator, you would say the natural log of 8 divided by the natural log of 2, or you could say the log of 8 divided by the log of 2. Regardless, you'll get 3 as the answer. Watch. The natural log of 8, the natural log of 8 divided by the natural log of 2, and you get 3. Okay? You get 3. That one was easy to do without the calculator. This one's not. You need the calculator here. So you have to use your base change formula. Base change formula. So according to the base change formula, and I'm going to stay with natural. I'm going to stay with the common logarithm. So that's your natural logarithm. That's your common logarithm. So I'm going to get the log of 6.8 divided by the log of 2.73. And so now, using your calculator, always remember you got to use parentheses when using your calculator. So using your calculator, I have the log of 6.8, close the parentheses, divide by the log of 2.73, close parentheses, press equal, and to 4 decimal places, you got 1.9087. Since this is less than 5, the 7 stays 7. So you're going to get 1.9087. All right, so that's the answer there. And then finally, 3C, you have the log of 8, and the base is 0.75. So base change formula, I can write this as the log of 8, base common logarithm, so base 10. So I can use the calculator, divided by the log of 0.75. And so we get, in this case, the log of 8 divided by the log of 0.75 equal, and you get negative, this time negative 7.228, and then since this is 5 or larger, this 2 becomes a 3. Okay, so make sure you know how to round off to 4 decimal places. So you get negative 7.2283. Okay, and so that is the key to this worksheet. So remember, to understand this, you need to make sure you know your properties of logarithms. All right, so that's the key to this worksheet.